Back, this is 4.8, example 4. We're going to actually use a coordinate proof. I'm not opposed to these. I think what drives me crazy is probably the vagueness of knowing, I don't know the actual distances, and that drives me crazy in general. So we are going to suffer together and figure this out together, and we're going to be just fine. We're going to prove that the triangle whose vertices are the midpoints of the sides of an isosceles triangle is also isosceles. So what they've done is, this is what they've done. Let me kind of redraw it. They said, okay, here's an isosceles triangle, okay? So we know that, if we call this A and this B and this C, they're saying, okay, well, AB is congruent to AC, okay, because it's an isosceles triangle. So let me change colors. Let's change to red. And they said, okay, now you've got vertices and you've got midpoints. So we've got now this point, X, is the midpoint of AB. Y is the midpoint of AC. Z is the midpoint of BC. Prove that this triangle is also isosceles, okay? So our goal is to figure out, does XZ is that actually congruent to YZ? That's really what we're after. That's what we're trying to prove. And if you were like, I didn't really understand the figure when I first saw it, that's the breakdown of it. That's what they're trying to get you to do. So again, we're back to this positioning in the coordinate plane. We do want one of the points to be at the origin. It's not a right triangle, so you cannot use both axes. You can only use both axes if it's a right. So we know that B is at 0, 0. Remember what we talked about. We said when you name some of these other points like C and A, you want to make sure that you're using a multiple of 2, okay? Now, you're probably wondering, you're probably looking at that going, why did they call C 4A 0? Okay, well think about the midpoint. What's halfway between 0 and 4A? What's half of 4A? 2A. So that's the reason why they went with 4A, because they know that we need to use a little bit higher numbers, a little bit higher multiple. Since we're working with two separate triangles here, we're going to have to probably do the midpoint formula and the distance formula. We want to make these numbers as easy as possible on us, okay? So that's why they call point C is 4A 0, because we know that Z is going to end up being 2A 0. Okay, it's going to be the halfway point, basically, of BC. So if Z is at 2A 0, because all 3 points are on the origin, B, Z, and C are all on the x-axis, so that Y coordinate has to be 0 no matter what. So 2A is half of 4A, so that's why we want to call Z 2A and therefore call C 4A. I don't know if that made any sense at all. It makes sense to me. I'm looking at it. I'm hoping I'm explaining it well. Okay, now if you look at point A and you see in the diagram above, you're like, well, why did they call it 2AB? Well, the 2A is easy. Z is directly underneath A. Okay, Z is directly underneath A. So if you go out to A, that's going to be the X part of point A. Now you're going to go up. Now it's up to you to decide how far up, what do you want to call, call that B coordinate, that Y coordinate, what do you want to call that? And they just went with 2B instead of 4B, like the other one. They went with 2B. Because we know if we have to take half of that, it's only going to be 1B, and that's fine, okay? So anyway, I don't know if I explained that well or not, but the derivative of the name of this point, A is easily ascertained because A is directly over Z, so that X in the Z point is also the X in the A point, okay? And then you had to decide what this point is here, what that distance is. So if you're calling that 2B on your graph, then that's the Y on that particular graph. So that's what we're going to use. We're going to call point A is 2A, 2B, point B is 0, 0 at the origin, point C is 4A, 0, and then we're going to go through the rest of it, try and figure it out little by little by little, okay? All right, so the midpoint formula, we want to find the coordinate for X, Y, and Z, okay? And Z we already know. Z was easy. You could do that without the midpoint formula. That's 2A, 0. All right, so X and Y, that's what we're after. Okay, so let's start there. So the first thing we want to do is find the midpoint of AB. So I'll put a little AB out here to remind you that we're finding the midpoint of AB. So we've got to add our X's. So that would be 2A plus 0 and divide that by 2. We're going to do that with the Y's. 2B plus 0 divided by 2. So that means that this particular midpoint is at AB. Okay, 2A plus 0 is 2A. 2A divided by 2 is just plain A. That's all it is, just an A. 2B plus 0 is 2B. 2B divided by 2 is B. So now we know the X coordinate. Okay, now let's go over to the other segment. Let's do segment AC. And we're going to do the same thing, do the midpoint formula for that one. So now we're going to add our X's together. So that's going to be 2A plus 4A divided by 2. And then we're going to add our Y's, 2B plus 0 divided by 2. And let's see what we end up with. 2A plus 4A is 6A. 6A divided by 2 is 3A. 2B plus 0 is 2B. 2B divided by 2 is B. So that's the name, the actual name of that midpoint for Y. So this is X, this is Y, and we already know Z is 2A, 0. Okay? So we need to know those points because we are trying to figure out if that red triangle that I drew here is actually isosceles. That's what we're trying to prove, and we need to know the names of the points so that we can use the distance formula. I don't know if you remember the distance formula. This is where we take our X's, subtract our X's, square them, and then we're going to take our Y's and square them, add those squares together, and take the square root of that sum, and we're going to see what the distance is. Okay? So in order to use this formula, you have to know 2 points. So if we're trying to find the distance of, let's say, X, Z, okay? Well, X, its coordinate is AB, and Z's coordinates are 2A, 0, okay? So if you need to label them, go right ahead. Call that X1, Y1, X2, Y2, whatever you need to do to keep it straight, because there's a lot of letters flying through here, okay? It's easy to mess this up. Okay, so first thing we want to do is subtract our X's. That would be 2A minus A. We're going to square that. Plus, let's do the same thing with the Y's. 0 minus B. Okay, so 2A, I'm going to start here. 2A minus A, well that's 1A. So that's A squared plus, and then 0 minus B is negative B. Negative B squared is just plain old B squared. Okay, the sign's going to cancel out. Anytime you square a negative sign, it cancels out. Okay, so that is actually the length of XZ. Okay, now we're going to go back and do it again. This time we're going to find the length of YZ. Okay, we already know what Z is. Remember that's 2A, 0. And I'll rewrite that. 2A, 0. That's Z. Okay. And Y is 3AB. 3a comma b. Okay? So again, you want to, assign one of the points to be 0.1. So you can call this one x1, y1, x2, y2. Whatever works for you works for me. I don't really care. It doesn't matter which one's 0.1, which one's 0.2. And then we're going to plug into our distance formula. So we're going to subtract our x's. So 3a minus 2a, square that. And then we're going to do b minus 0, and we're going to square that. Okay, so let's take a look. 3a minus 2a, that's 1a, so that's just a squared. B minus 0 is b, plus b squared. Now take a look at your two lengths. Are they the same? Yes, they are. And so we were able to prove that the length of xz is equal to the length of yz. And so we can say, yes, that little triangle on the inside is definitely isosceles. So here, YZ. Okay? And so that's what they wanted us to do, is prove that XYZ is isosceles, and we did prove that. We just had to show that two sides were equal, and we did that with the distance formula. The hard part was we didn't have any numbers, and we had all these letters all over the place, very abstract, but hopefully you were able to track me. If not, we'll just redo this one in class tomorrow. So you just let me know if you didn't understand it, and we'll just I'll go a little bit more slowly and make sure you know exactly where you went wrong. So if you kind of know where you lost me in the problem, mark that, so when I ask you tomorrow, I can talk to you about it. Okay? Thanks for listening.